Good morning. All right. So I've got five more of our examples from the practice exam that I want to go through today. So that's it. Just a couple of reminders that test 5 is due by midnight tonight. So if you have not completed and submitted that yet, just make sure you get test 5 done and submitted by tonight so that I can get those graded over the weekend and let you know kind of what your grade is going into that final exam. Also, if you have not scheduled a time for the final exam, and you're even considering taking the final exam or plan to take it for sure, go ahead and sign up for a time. You can do that by going to the announcements, finding that link to sign up for an exam time. All you got to do is put your name in there, select the day, select the time. It's real quick and easy. Make sure you do that so that I know you're planning to take the exam, and I have a time reserved for you and an exam for you. Okay. Welcome to the last day of class. So this is it. This will be all we do. We will not meet next week at all because next week I just want everybody focused on final exams and I have to focus on grading final exams. So there will be no class meetings next week. If you do still have any questions or anything, I am available, but we will not meet for class. Okay? Any questions about anything right now before we get started today? All right. So let's take a look at example 18 then. All right, so we're given a polynomial here. We want to find all the zeros algebraically and then use that to factor completely that polynomial. All right, so what's the first thing we're going to have to do in this case if we want to find all the zeros? P's and Q's, good, right? So this is where we're going to list out our P values, list out our Q values, find our possible rational roots, right? And then we test those. So if we do this, what are the P values going to be this time? Okay, so plus or minus 1 be 1, right? And then we've got 7, 8, 48, 150. Sorry, let's see. So I agree with a lot of those. All right, so let's just make sure we've got all the correct ones. So first off, this is where we're looking, right? We're looking at the 135. We got to find all the factors of 135. All right, so what are the factors of 135 this time? And even if you don't have them all in order, right? If you just start listing out some factors, we can go back and make sure we've got them all. Okay, so 1 and 135, that would work, right? So plus or minus 135 is another factor. 5 times 27, okay, that works. So we have plus or minus 5 and plus or minus 27. Okay, anything else go into 135? Okay, 3 and 45, good. So plus or minus 3 and plus or minus 45. And then 9 and 15 should also work. Good. So plus or minus 9, plus or minus 15. And I think that should be good now. I think that gives us all of them. So we got the 5 and the 27, 3 and 9. Yep, that looks good. Okay, so there's our list of factors for the 135. Now, what about the Q value? What are those factors going to be? Just plus or minus 1, right? Because now we're just looking at that coefficient. There's an understood 1 there, and so that's going to be plus or minus 1. So at least in this case, for our P divided by Q, it's still just going to be that same list of P values. So I'm not going to list it out again, but it's those same factors that we got for P because we're just dividing each one of those by 1. All right. Now, once we know the P over Q, now we can do what? Right, so that's what I just, so yeah, if you want to list them out, right, it's plus or minus 1 again, plus or minus 135, plus or minus 5, plus or minus 27, plus or minus 3, plus or minus 45, plus or minus 9, and plus or minus 15, right? Same as our P list, right, because we're dividing them all by 1. All right, good. So now we can look at the graph, just determine which ones we even want to check, and then we can use synthetic division to check those, right? So I'm going to put this in Desmos. If you have a graphing calculator and want to do this also, you can. I'll share this graph so we can look at it together. So we have x to the 5th minus 7x to the 4th plus 8x cubed plus 48x squared minus 153x plus 135. Okay. Okay, so there's our graph. Okay, so if we take a look at that graph now, what values does it look like we might want to check this time? Okay, so -3 and +3 are the places where it touches the x-axis, right? Okay, so -3 and 3 are the ones we're going to want to check. Now, is there anything special about 3 that we might need to consider in this case? Okay, it bounces there. What does that tell us about 3 then? Okay, that's right. It might happen twice. Okay, in this case, when we do our synthetic division, just keep in mind that this 3 right here is most likely going to be a double root, okay, because it bounces at that point. Okay, so it probably has an even multiplicity this time. All right, so now we need to go back and test. So let me switch back to my other screen. And so if we want to test, let's do -3 first. I'm going to put -3 in my box. All right, and we're going to do synthetic division here. So remember, we're going to list out all the coefficients. Always put zeros if you're missing any terms, but I have an x to the 5th, 4th, 3rd, 2nd, 1st, and then no x at all. I'm not missing any terms, so my coefficients are just going to be 1, -7, 8, 48, -153, and +135. So what's my first step in the synthetic division now? Okay, good. Bring down that first term. In this case, there's a 1 there. So then we're going to multiply. 1 times -3 goes under here. And now we're always going to do what with those values? Add. Good. Okay, so don't forget the addition. So now we have -7 plus -3 is -10. I'm just going to go through and do all this. -10 times -3 is 30. 8 plus 30 is 38. 38 times -3, sorry, I'm going to use my calculator, -114. Then we have 48 plus -114. That should give us -66. -66 times -3 should give us a positive 198. 198 plus -153 should give us 45. And now 45 times -3 is -135, and that will give us a remainder of 0. Okay, so now we know in this case, because we got a remainder of 0, that -3 is one of our zeros. That is a correct 0. Now what can we do from there? Good. Let's check the 3. And remember, we don't want to go back to the original coefficients here. We can actually continue with this line that we just got because we know that that's going to be part of our polynomial also. Okay, so since that gave us a 0 as our remainder, we're allowed to just use that line. Okay, so now we bring down the 1 again. We multiply. 1 times 3 is 3. We're always adding here. So negative plus 3 is -7. -7 times 3, -21. 38 plus -21 should give us 17. 17 times 3 is 51. -66 plus 51, I believe, is -15. And -15 times 3 is -45. And that remainder is 0. So now we know that 3 works. Now what? Yeah, let's check 3 again, because at this point, remember we started with x to the 5th. We've divided out 2 of our x's, so we're only down to an x to the 3rd at this point. We can't really do anything with that, right? We can't factor it, can't use quadratic formula yet. So let's check 3 again since it bounced there and see if that actually is a double root this time. Okay, so we're just going to bring down the 1 again. 1 times 3 is 3. Now we add, -7 plus 3 is -4. -4 times 3 is -12. 17 plus -12 is 5. 5 times 3 is 15. And again, we get a remainder of 0. So now we know that 3 is a double root, right? So it worked twice. So we know it actually happens twice when we do our factors. All right. So now, what do we get from that last line? Good. So that's x squared minus 4x plus 5, right? So this line down here now tells us x squared minus 4x plus 5 is a factor. And so now what we need to do is actually figure out what are the zeros that are going to come from that, right? So far we have -3, +3, +3. That's 3 of our zeros. We need 5 total, right? Good. We can't factor it, right? It may look like it's going to factor, but in this case, the 5 would have to have the same sign on the 5 and the 1, and that's not going to give us a -4. So we are going to have to use quadratic formula now. So I'm going to create a new slide. We'll do the quadratic formula. All right. So we had x squared minus 4x plus 5. So now if I do quadratic formula, remember that I'm going to write it over here. X equals negative plus or minus the square root of b squared minus 4ac all over 2a. So now if I substitute into that, my negative b becomes a positive 4 plus or minus the square root of -4 squared minus 4 times a is 1, c is 5. We're going to put all of that over 2 times 1. Any questions on the formula or subbing any of those in there? Okay. Now to simplify. I'm going to keep 4 outside here. 4 plus minus. -4 squared becomes positive, gives us 16. Then we've got -4 times 1 times 5 is going to be a -20. And then 1 on the bottom is just going to be 2. Simplify 16 minus 20. That gives us 4 plus or minus the root of 4 all over 2. What's the square root of -4 going to give us? 2i. Good, right? Because the square root of 4 is 2. The square root of a negative is going to give us an I. So we're going to get 4 plus or minus 2i all over 2. And now remember, as long as we can divide both of those terms by whatever's in the denominator, we can split that apart and do that division. So what's our final answer going to be here when we simplify that? Good. 2 plus or minus I. Because 4 divided by 2 is 2. Keep your plus or minus. 2i divided by 2 is just 1i. Right? So there's our last 2 zeros. 2 plus I and 2 minus I are the last 2 zeros this time. Right, now the last thing we want to do is just write out all of our zeros and then our factored form. So going back, we know our zeros were -3, +3, +3, right? That's what we got on the first slide. And now we have this 2 plus I and 2 minus I, right? And you should always have, whatever your degree is how many zeros you should have. And so we end up with 5 total zeros this time. Now, if you just want to list the 3 once, that's fine, right? So just keep in mind, though, it does count twice, right? So we do have our 5 zeros that we need. Now look about the factored form. Okay, so the -3 here, what's the factor that would give us -3? X plus 3, good. What's the factor that would give us +3? X minus 3. And in this case, because we have 2 of them, what can we put there? Yeah, we can just raise that to the second power, and that tells us that's a double root now. Now, the last 2 factors, what's that next factor going to look like for the 2 plus I? Good. X minus 2 minus I. Because remember, you're changing both of the signs in this case. And so then the last one here, the last factor is going to be x minus 2 plus I. Good. Because we need to make the 2 a minus. But then that minus I becomes a plus I. And so that right there is our factored form for that one. And so that's what I would be looking for, right? Is first off, find your P's and Q's, do your synthetic division to test, right? And if you need to use the graph to figure out which ones to test, that's fine. Then once you do that, if you get down to something that you can't factor, be sure to use quadratic formula, find all of those zeros, and then make sure that you write the actual factored form because it does ask for that here. Okay? Any questions on that one now? All right. The next one I'll look at is 19. Okay, so we've got a rational function here. We're asked to find intercepts, describe end behavior. Actually, on the exam here, I'm just going to ask you for domain instead. Okay, so that's what we're going to find. All right, so intercepts, domain, and any of our asymptotes. And that includes vertical, horizontal, and then any possible slant asymptotes we might have. All right, what's the first thing we're going to want to do with this rational function? Okay, so we could find vertical asymptotes, right? But the first thing we're going to want to do is factor as much as we can, right? Because that's going to tell us if any factors cancel out first before we start looking for those asymptotes. All right, so let's look at the numerator first. Can we factor anything in the numerator? Good, there's a common factor of x. So I'm going to bring out, that's going to leave me with 2x squared minus 5x minus 7. We'll go back and see if that factors any further in just a minute. What about the denominator? Can we factor that? Good. Right, it's x plus 1 and x minus 2, and that would give us what we started with there. All right. Now let's go back and look at the trinomial that's left over in the numerator. Let's see if we can factor that even further. So how would you factor 2x squared minus 5x minus 7 now? All right, so 2x minus 7, and then x plus 1. Good, because that'll give us 2x squared. We'll have a positive 2x and a negative 7x is negative 5x, and then negative 7 times 1 is negative 7. Okay, so that looks good. Now, once we get everything factored, okay, what do you notice? Yeah, the x plus 1, we have a common factor on top and bottom here, so we can actually cancel out that common factor of x plus 1 this time. So really the only thing that's left is the x times 2x minus 7 over the x minus 2. Now let's start looking at, somebody said vertical asymptotes, right? So let's start with that. So how would you find the vertical asymptote for this one now? Okay, so we're going to set the remaining factor here, right, whatever's left in the denominator, equal to 0. And so that's give us x minus 2 equals 0, right? And so what is that? That's fine. What's that going to give us then for the vertical asymptote? Good. So just x equals 2. And in this case, it is a vertical line, right? So just make sure you have the entire equation. X equals, don't just tell me 2. Actually write x equals 2 to say that it's an entire vertical line there. Okay, so there's our vertical asymptote. And again, that's why it's so important to fact first, right, and see if anything cancels. Because otherwise, if you just focus on the denominator, you might think that x equals negative 1 is a vertical asymptote, but because it cancels out, it's not actually a vertical asymptote anymore. Okay? All right. Now, what about horizontal asymptotes? Let's go there. So how do we check for horizontal, or what do we look at to determine horizontal asymptotes? Good. All right. So we start with the exponents on top and bottom. We look at the degree, right? And so in this case, if I look at my degree on top, we have a 3. My degree on the bottom is 2. And so what's our rule here if the degree in the numerator is bigger than the degree in the denominator? What does that tell us about our horizontal asymptotes? Good, there are none, right? So in terms of horizontal asymptotes, because the degree on top is bigger than the degree on the bottom, there are no horizontal asymptotes this time. Okay? And just go back and review those rules. If those degrees had been the same, then you would divide the coefficients here. So we'd have 2 divided by 1, which would be 2. If the top is smaller than the bottom, then it's always just going to be y equals 0, right? So those are the 3 cases, but in this case, we have a bigger degree on top than the bottom, so there is no horizontal asymptote. Now, because there's no horizontal asymptote, what do we need to check for now? Slant, right? So now we actually need to find the slant asymptote. And how do we find slant asymptotes? Long division. Good. So I'm going to take what's on the bottom here. I'm going to put it on the outside. So we have x squared minus x minus 2. And on the inside here, I'm going to put the 2x cubed minus 5x squared minus 7x. And if you want to put a 0 down there at the end, you can. I don't think we're going to need it because I think we'll get what we need without it. All right, so now remember our process for long division. We're going to look at that first term on the outside. We're going to look at that first term on the inside, and we're going to ask ourselves how many times does x squared go into 2x cubed? So in other words, what is 2x cubed divided by x squared? What is that going to give us? Just 2x. Good. So we have a 2x. Now we're going to multiply. So I take 2x times x squared. That's 2x cubed. 2x times negative x is negative 2x squared. And 2x times negative 2 is negative 4x. And now we have to subtract everything that we just got there. Okay, so just make sure you're distributing the 2x to everything on the outside, and then we're going to subtract that entire line there. As long as we did everything correctly, the first term should cancel. So 2x cubed minus 2x cubed is good. Negative 5x squared minus a negative 2x squared, that becomes addition. So this is going to be negative 3x squared. Negative 7x minus negative 4x becomes addition also, and that gives us negative 3x. Okay. Any questions on that step? All right. So again, we're going to look at the first term on the outside, first term under here. So now what's negative 3x squared divided by x squared? Just negative 3. Good. So we put our negative 3 up here. Again, we're going to distribute. Negative 3 times x squared is negative 3x squared. We have negative 3 times negative x becomes positive 3x. Negative 3 times negative 2 becomes positive 6. And so technically, yeah, we could put a 0 here, bring down the 0. Now we're going to subtract. So we end up with the x squares cancel. Negative 3x minus 3x is actually negative 6x. And then 0 minus 6 is going to be negative 6. Right. Now, at that point, can we go any further? No, right? So we can't divide negative 6x by x squared, right? So that right there is our remainder. But now, what's the slant asymptote going to be? Good. Just the 2x minus 3 part. And just don't forget, it is an equation of a line. So y equals 2x minus 3 is going to be our slant asymptote. So whenever you do your long division, all we care about is the quotient, right? The remainder doesn't make any difference here. So we're just doing the 2x minus 3. Just make sure you write it as y equals that. All right. Any questions on the slant asymptote now? All right, let's do our intercepts next, right? And I'll start with x-intercepts. How do we find an x-intercept? You could, right? So you could look at the graph here. What I'm going to do, though, I'm going to try to do this algebraically. And so remember, the x-intercept means that the y value is 0. So I'm going to set my function equal to 0, and I'm going to solve for x. Well, fortunately for us, we've already factored everything. So really all I have to do is set the numerator of my fraction equal to 0 in this case. And it's only whatever's left after I've canceled stuff out, okay, because that factor that canceled can't be an x-intercept there. I'm looking at my factored form, just the numerator, and I'm setting that numerator equal to 0 because that's like setting the entire function equal to 0 now. Now that it's factored, I can just set each factor equal to 0. So that's going to give us x equals 0. And then 2x minus 7 equals 0. What's the 2x minus 7 equals 0 give us as the x-intercept? 7 over 2. Good. So just add 7, divide by 2. So now we know our x-intercepts are going to be at 0 and 7/2. So the denominator, remember, can't be equal to 0 because that would make it undefined, and that's why we completely ignore the denominator when we're finding those x-intercepts. The denominator is only going to help you to find asymptotes, but it's never going to help you find your intercepts. All right. What about y-intercepts? How would you find a y-intercept now? Just plug in 0 for x, right? So I'm going to take my function here. I'm going to plug in 0 for the x. And it doesn't really matter where we do that. I'm going to do it in that factored form again. That's going to give us 0 times 2 times 0 minus 7 all over 0 minus 2. But in this case, because I'm doing 0 times something in the numerator, it really doesn't matter what I'm dividing by. What is y going to be equal to now? Just 0, right? Okay, because we know the numerator is going to come out 0 over negative 2 is still 0. So our y-intercept is 0. Okay, you should only ever have one y-intercept if it's a function. Okay, so just keep that in mind. If it's a function, you're only going to have one y-intercept. You can't have more than that. All right, so the last thing we got to find now is domain. So how are we going to find the domain of this function? Okay, so in this case, right, the vertical asymptote is one restriction, right? But even though the x plus 1 canceled out here, it's still a restriction on our denominator, right? Because our denominator can't be 0. And so we're still going to have that x plus 1 can't be equal to 0. And x minus 2 can't be equal to 0, which means that x can't be negative 1 and x cannot be equal to positive 2, right? So that's the one thing we have to be careful of there is, yes, the vertical asymptote is a restriction. However, the factor that canceled in the denominator is still a restriction also, right? So we have to remember that one. So now, where are we going to start our domain? Okay, so not 0, right? What's the smallest possible value I could have here? Negative infinity, right? So we're going to start all the way back at negative infinity. We're going to go up to that first restriction, which is negative 1, but we don't want to include negative 1, so we're going to use parentheses there. Then we're going to have a union. What's the next part of our interval going to look like? Good. So from negative 1 to positive 2, again, not including either of those values. Okay. And the reason we don't want to stop at 0, right, is because 0 is not a restriction, right? And we can see that there's an x value of 0 and a y value of 0. That's actually the x and y intercept there. So we're fine with that, right? The graph is actually going to pass through that point. Okay, so now we've got from negative 1 to 2. Now we're going to go from what? Good. From 2 all the way to infinity. That's going to be the last piece of our domain now. So we're only looking at those restrictions that we get from the denominator. That's going to give us where we want to break our intervals for our domain. And so the only restrictions are at negative 1 and positive 2 this time. Any questions there now? Yes. So there is a hole in the graph, right? The hole would be at negative 1, and no, it's not included in the domain, right? So that's why I said the vertical asymptote is definitely one restriction, okay, but that negative 1 is where the hole would be, and so that's also another restriction, and so that's why we don't include negative 1 in our domain now. Any other question? All right. We're going to skip all the way to 29. So here's one of our exponential growth type problems. Okay, so we have the count of a culture of bacteria is 900 after 2 hours, 112,500 after 5 hours. We want to find the function that models the number of bacteria n of t after t hours. All right, so first off, what's the formula we're going to want to use here to help us model this situation? All right, so for time's sake, I'm going to do it. It's n of t equals n sub 0 times e to the RT, right? Very similar to our PERT formula for compounded interest continuously, right? Okay, but now we're talking about a population of bacteria. Okay, so we just use the n sub 0 as the initial population. Now we have to figure out what information we know, right? So we don't know the initial population in either case. We do have a time for both, and we have an overall population for both. So the way I'm going to do this is I'm going to say, well, I've got one equation that would be 112,500 equals n sub 0 e to the r times 5, because I don't know my growth rate, I don't know my initial population. But then I have this other situation here where 900 is equal to n sub 0 e to the r times 2 instead. So we're using that same formula in both cases. We're plugging in the information we know, but in both, we don't know the initial and we don't know the rate. Okay, those are the things we're missing in this case. Now, this is a question very similar to the last test, right? So what did we at that point? Divide, right? So we're setting up a proportion here. So I'm just going to divide both sides of this equation. And so now we can simplify this. So we have 112,500, dividing that by 900. So that should give us 125. What are we going to get on the right-hand side when we divide that? Okay, good. And it's going to be E as the base still, right? So E to the 3R, because the n sub zeros here are going to cancel each other out. And now we have e to the 5r over e to the 2r. And since we're dividing, we can subtract exponents. 5r minus 2r gives us e to the 3r now. Now, how would you solve that equation for r? Take the natural log, right? So we have natural log 125. When I take the natural log of the other side, what are we going to get? Just 3r, right? Because the natural log and the e cancel out. We bring the 3r out of the exponent. And so now we just have to divide. So we have natural log 125 over 3 is our r value. Questions on that step? All right, now we just got to take the r value, plug it back in, and we can solve for n sub 0. I'm going to use the 900 equation here, so I'm going to go 900 equals n sub 0 e to the natural log 125 over 3 times 2. And at that point, right, we have all of this stuff here that's a number. We can actually put that into the calculator and then just divide 900 by all of that. 900 divided by e to the natural log 125 divided by 3 times 2. And when I do that, it gives me a nice answer of 36. Okay. Now, again, if you had used the decimal there, right, it might not work out to exactly 36, but it should be close enough that you can see we can probably just round it up to that, right? But in this case, it is an exact value of 36 if you do the division. Okay, so now we're just going to put all that together into that formula that we up top, right? So we're going to have n of t equals 36 e to the natural log of 125 over 3 times t. And that is our formula now in terms of t that models that situation. Any questions there? All right. Now, how are we going to set up part B here? Good, right? So we're just going to set that equation we just found equal to 2,000. We get 36e to the natural log 125 over 3 times t. What's our first step going to be in solving that equation? Good, so we divide. When we do that, I'm just going to keep it as a friend. It's going to simplify to 500 over 9 equals e to the natural log 125 over 3 times t. Then we have to do what? Take the natural log. Good, so we have natural log 500 over 9. Over here now, the e and the natural log cancel out, so I'm just bringing everything out of the exponent. So that's natural log 125 over 3 times t. And so now what's the last step going to be? Yeah, just divide, right? So we're going to divide by the natural log of 125 over 3. And if you don't want to write that as a decimal, just be really careful with parentheses and stuff. Okay, but when we do all of that, and we should get 2.496 hours as our value. So again, just be real careful. You might even want to just go ahead and 25 over 3, get a decimal value for that, and then do your natural log of 500 over 9 divided by the decimal, just to make sure that you're not messing up parentheses or anything else down there in that denominator. Any questions on that one? Thought you multiply by 3. You could, right? So you could multiply by 3 and then divide by natural log of 125. That would give you the same thing, right? So dividing by the entire fraction as a whole would be multiplying by 3 first, then dividing by the natural log of 125. Should get that same either way. Okay. Any other questions? All right, so I want to get through at least one more here. The next one I want to look at, trying to decide between 31 and 32. Let's do 32 because I want to make sure we're clear on how to set up. But 31 is just solving algebraically a system, okay? So just remember in that case, you're going to eliminate a variable, try to combine, get it down to another variable, and then go back and back substitute, right? So we've done a lot of those types of problems. So I think I'd rather do 32 and try to set this one up. But remember, you can use matrices once we get the setup correct. All right, so we have a piggy bank containing 50 coins. All of them are nickels, dimes, or quarters. Total value of the coins is $5.55, but there are twice as many nickels as quarters. We want to know how many coins of each we have. So what's the first thing we're going to do here? Okay, so in this case, right, we know we have nickels, dimes, and quarters, right? So I'll let n equal my nickels, d can equal dimes, q equals quarters, find those variables. All right, and so then you said n plus d plus q equals 555. So what do we think about that? So if n represents the number of nickels, d represents the number of dimes, and q represents the number of quarters, it should be equal to 50, right? Because if I add together the number of each of those things, I know I have 50 coins in total, so there's going to be my first equation, right? So nickels plus dimes plus quarters has to be 50 coins in total, right? There's one equation. What's another equation going to be? Okay, so the number of nickels is going to be twice as many as quarters, right? Because there's twice as many nickels as quarters. Good. So it's going to be n equals 2 times the number of quarters. And just be really careful with that equation. It's really easy to put 2n equals q there. Right? But we want the number of nickels to be twice as many as the number of quarters, so that's why it's n equals 2q instead. Right, now we still need a third equation, right? Because we have 3 variables. So what's that third equation going to be? All right, so we have 0.05, right? Because that's the value of a nickel. We're going to have to multiply that, though, by the number of nickels, right? So don't forget your variables in this equation. So it's going to be 0.05n. Value of a dime is 10 cents, so 0.10d. Value of a quarter is 0.25q. And then we know that the total amount of money that we have is $5.55. So that's going to be our second equation. And we have our third one down at the bottom. Now, what I would suggest at that point, because again, on a word problem like this, I'm fine if you use matrices. I'm going to just move this 2q to the other side and write this as n minus 2q equals 0. Now I can set this up as an augmented matrix, and I can use my reduced row echelon form in the calculator. So we're going to have 1, 1, 1, 50, 0.05, 0.10, 0.25, 5.55, and then we have 1 for the n. We have 0 dimes here, negative 2 for the q, and 0 for our constant. And if we do that, we put it into our matrix, we do our reduced row echelon form. should give us 22, 17, and 11. And so what that tells us is we have 22 nickels, we have 17 dimes, and we have 11 quarters now. Okay, so that's kind of what I'd be looking for on that one. So if it's a word problem, set up your equations, right? Define your variables, and then if you want to use matrices, you can. If you wanted to do substitution and do it algebraically, you could also do it that way, but feel free to use matrices on a problem like that if you want to. Okay. And again, I would go back and look at number 31. We didn't have time to do that one, but just make sure you're comfortable solving a system of 3 variables algebraically, because you'll probably see one that you have to do that way also. Okay. Any last minute questions? All right. Well, it's been a pleasure, everyone, and good luck with all of your final exams. Let me know if you do have any questions, right? I'm still here, right? So email, let me know if you have questions about anything. 10 questions on the final, so that's what you can expect. And again, they should be pretty similar to what we just went over. Basically, a couple from each unit, right, is what you can expect to see, but it will be 10 total. Anything else? All right. Well, have a great afternoon, weekend. Good luck on your finals, and I will talk to you later. But again, if you have any questions about anything over the weekend or otherwise, please let me know. But good luck.